we'll see sorting first, and then we'll see about the rest of the. Yes, to store the homogeneous type of data structures together. Yes. Storing different type of data together, it's almost the same one. Storing data in sequential manner, yes, because the array itself is a sequential in nature, so we will say that, yeah. So let's just see for the first point, sorting. You might be thinking that, hey, we have understood the sorting in BTech and all that things, but when it comes to the interview, sorting is also important. Why? There are many types of sorting. On top of that, interview questions will be built, so it's very necessary to clear our fundamental when we are entering into the industry, or even when we are giving interviews. Okay, so that's why I have taken some topics which are a little bit old for you guys, but still it's very important to understand them from the root. So very quickly we'll see sorting, one or two type of sorting probably, and then we'll forward it. Okay, so sorting, yes, sorting of the data is much more important. Tell me what all types of sortings are there and what is the best. I know everyone would be knowing it, so we'll not wait. The best is quick sort. Another is merge sort. Then there is bubble sort. Then there are many pigeonhole, and so many things are there. Okay. Insertion sort is there. There is a sorting mechanism with a graph as well. So many things are there. In industry, like let's say you might be using C++, right? Or you all would have used it. Or let's say you are using Java. At that time, let's say you have some array A. Okay. And you write some syntax, something like this, array.sort. Just array.sort. So by default, it's in increasing order. Which sorting mechanism it will use? Internally. No, not bubble. Not merge even. Combination? Probably.
It's a combination of quick and merge sort.
Exactly. So it's a combination of a quick and merge sort. So that's why we'll first see the quick sort, and then we will see about the merge sort, how it happens. And we'll also see why quick sort is always preferable. I hope everyone would know it, but quickly we'll see that. Before that, we'll just understand about the time complexity of both. Okay, and then we'll start either a quick sort or a merge sort, just to explain just a sorting mechanism. Okay, so quick sort is best when the data is random. If it's already sorted or partially sorted, then it will not give the best time complexity. The reason behind that is, we'll quickly see how quick sort works. I won't go in much depth of coding right now, but what quick sort does is, first it takes the pivot element. So pivot element means some element. Okay, now let's say it has taken X as an element. How it chooses X element, we'll see. What it does second is, it fixes X position. Now how it does is, that also we'll see. And third, it will loop again and find it out the next pivot element. Okay, so this just, if I say, it's a two-step procedure, but each step in depth has a different logic. Like let's say getting a pivot or finding a pivot element. Either pivot element in the sense, from array, you need to find it out one element on which you want to do operation. So either you can choose either, let's say, first index, or you can choose the last index, or you can choose a random index, or you can choose always a middle index, something like first plus last by 2, correct? Like that. So you're choosing some element from the array which is fixed every time in the sense whenever a loop will restart, you'll choose any one from this every time. So if you're sticking with first, your code will every time choose the first element as index. Then what you do? Then you find it out all the elements. In second step, fix its position. So while fixing its position, what you do, you find it out all the elements which are lesser than x, and you put it at the first, all the elements which are larger than x, and you put it in the backside of the x. So let's say, just taking a random example of array, let's say 2, 8, 1, 3, 12, and 9 is there. And if I have chosen 9 as in a pivot, what will happen is, after the first iteration, my 9 will come over here, and all the elements which are smaller than that in the same order will come over here, something like, let's say 2, 8, 1, 3, and 12 over here. And then the same logic I'll apply over this portion of array and this portion of array as subarray. So the 9's position is fixed. In the same way, I'll fix the position of all of this and the rest of the elements if there are in this. And in that way, a quick short will be done. Now in interview, I have seen that the variation of quick short is being asked. Sometimes when you are new joining, they will ask you simple, write a full functioning code for quick short. Quick short is tricky, that's why. So that's why, as I said, whenever you're going for an interview, start from the basics and till the last topic, you should be prepared when you're going in the backend interview for data structures and algorithm. Make sense? Yeah, the recorded will be given. You can ask into WhatsApp group as well. Sorry, there is another group on that you can ask. Okay.
Can you please share the link for the group?
Yeah, I think this group link of Telegram is already shared, but post the session I'll reshare. Okay, that so that you can ask about your certificate, recorded sessions, your exams, but you'll have to give some. So all the things will be provided post session. Okay, so let's stick to the technical things.
Sir, will you explain it again, sir?
We'll quickly go. Okay, what quickshot is and how it works. So as I say, quickshot works in 2 steps: finding a pivot and fix its position. Finding pivot means you choose an element for which you want to fix its position. Every time, in every iteration, it will be the same. Let's say the 9 you are choosing. It's the last index you are choosing. So let's say 9 is chosen from here, last index. Then in second step, what you do, find all the elements which are smaller than that and all the elements which are greater than that. And you put such a way that all the elements which are smaller than that should be before x, and all the elements which are greater than x should be after x. So after the first and second step, your 9, let's say for this example, input array, will be kept over here 9, and all the smaller elements are towards its left side, all the greater elements are towards its right side. Post that 2, 8, 1, 3, 9, 12, and consider, let's say 15, 13. This is a larger array. So this as an a subarray and this as an a subarray will be called again. Will be called again means, again I'll call the quickshort function with first index as this, last index as this, first index as this, last index as this. As it's an array, the rotation and whatever happens or sorting happens, it will happen in place. So let's say in 3, if I again find its position, 3 will be kept over here, right? So 3 will be kept over here, rest of the elements again over here, rest of the elements again over here. 9 will be as it is. Again, over here 13, when I find it out, its position will be 13 and 15, like that. Correct? So in this way, quicksort works. Yeah, link will be shared. Okay. Post that, we'll have to redo the process again and again until we find a least element, means least element in the sense least number of elements into the array. So let's say 1 or 2 is the size. Till that time, we'll recursively call and we'll stop. Now, merge sort also works in almost similar way. Let's see how merge sort works, and then we'll see why quicksort is better than merge sort. So yeah, this is the representation of quicksort very quickly. Let's say over here I'm choosing the, so this is for all who wants to understand quicksort very again. So over here in this example, I'm choosing the first element as pivot. Please mute everyone. Yeah, so over here I have chosen the first as a pivot. What I do after choosing a pivot, I fix its size, or sorry, fix its position, all the smaller elements in a same order, 1, 3, and 2. They are kept to the left of it, and larger element towards the right of it, 8, 7, and 9. And then I do the same process towards the left side and towards the right side. Again, the finding of an element, pivot element, again I'm choosing, and again the 8 is I'm finding as a pivot, and I'm redoing the same process again and again. And at the end, once I have none left, I'm just completing the merge process. In a simplistic way, quicksort works like this. Now, where is merge sort? Merge sort always divides an array into 2 parts, always. And it divides until it finds the smallest such subpart, either 1 or 2 elements. When it finds that, it starts merging. So this is called division. And then after that, it will start merging. It's called conquer. So it's in a type of divide and conquer algorithm. What it does, so let's say array is divided into 2 parts. So it won't be like I'm creating 2 different array, but what it will do, the first and the last index in recursive order will be defined separately. In this, the first and last will be this one. Over here, first and last are same. And over here, first and last are this. When the first and last both are same or +1 in number of like first equals to last -1, such kind of condition happen, at that time we will stop. And what we will do further? Further, we'll start merging them in a proper order. So when we know that there are only 2 elements, we'll sort them. Which one is larger, put it first, swap them, keep it. There is only single element, keep it as it is. There is 2 elements, sort them, keep it as it is. And while merging, again, we'll do the same process. We know this is sorted. So we'll find it out that what is least, 1 or 3. 1 is least, put it over here. Then 5 or 3, which is least. Whichever is least, put it over here. Whichever is remaining, kept it at last. The same way, 4 or 2, whichever is least, 2. So first kept it. Then 4 or 6, 4. So then let's keep it. And then remaining 1, 6. So let's keep the 6 as it is. And then again, the sub-arrays are merged. 1 and 2, whichever is least, kept it as it is. And furthermore, the merge sort completes. Right? So the difference between quicksort and merge sort is fairly simple. It divides always. Now over here, if you have seen this example, let's say this example, let's say if this is already sorted, right? We will not have to divide it furthermore. That is first thing. Let's say second thing is that just in our different example, 2, 8, 1, 3, and 9, or let's say 12 is over here. In this example, we find it out that 2, 8, 1, 3, 9, and 12 just after our first iteration. Then it won't be divided always, right? Because we find it out that in one subarray, we have only 1 element. The same case doesn't happen over here. We'll strictly divide it into 2 subhalves. So that's why it's always that its space complexity will be what? And time complexity will be what? Everyone knows about from their college. What is the time complexity and space complexity of merge sort? And what is the time complexity and space complexity for quick sort?
Both have the same complexity.
Exactly. Both have same complexity in terms of time complexity and space complexity. Okay. But as it requires in complexity wise, mathematically, they both are same. If I say one more word, that mathematically merge sort is better than quick sort. Why? If an element is already sorted or reversely sorted, then if we apply quick sort, then it will be order of n square time complexity. You know it, right? Why is it so? Let's take a simple example and quick example. Let's say we have 1, 2, 3, 4, and 5 already sorted array, and I'm applying quick sort over that. What will happen? I choose 5, find it out. So if I'm choosing a wrong pivot at that time, if I'm choosing 5 as a pivot, my code is at this. I'll put it 5 at its own place, try to find whichever the elements are larger than that. I won't find anything. So there is nothing operation is happening. And again, I'll call the function for rest of the subarray. So now in 1, 2, 3, 4, again, I'll find a pivot element, which is 4. I put it at the same position. And again, I'll do recursively same. So effectively, I'm reprocessing the same array. We are not dividing and conquering. So that's why when in quick sort, your input is sorted and you are choosing a pivot in such a way. If it's reversely sorted and you're choosing the first pivot or last pivot in that, then it gives you order of n square. So it's called worst case complexity. So worst case quick sort is not better. Who did this? I don't know how to erase this as well. Okay. So quick sort gives order of n square in worst case, while merge sort always gives order of n log n in average or worst case, because every time we are dividing it from the half. Okay. So now we are waiting for questions if you guys have any. Yes, code we'll see. I hope quick sort and merge sorts code are fairly simple. You guys might remember it. So I'm not going into the code for this. We'll take some interview questions rather than that. After seeing some basic usages of array in industry. So we'll take a pause for a minute or a two, and we'll start. Okay. So as I said, the array will be used mainly, as people say, for sorting, not normal sorting, but generally when we are storing files, we are storing files in a large data center or somewhere. They are indexed, obviously, right? Indexing uses array. Furthermore, if I say array is used for scheduling, probably you'll think like, how? Yes, Raj, sessions will be given. So we know that for scheduling, queue is used. But queue can be implemented internally with array and linked list. Both the ways it can be used. Generally, at the C++ level, if I say, it is used as in a terms of array only. And that's why I can say that array can be used for scheduling as well. Now, what are the types of schedulers? We know many examples: shortest job first, or shortest job first come first serve, largest job first, shortest remaining time, round robin. So many scheduling algorithms are there. If you see the implementation of those, the jobs, sorting, rest of the things are happening with the help of array only. Yes, we are using queue, but queue's implementation can be with array or with linked list. And normally, the scheduler or a queue is mostly used data structure in industry. Mostly used. So if I give you an simple example, when you put an order into, let's say, Amazon, Flipkart, Walmart, anywhere, right? For everything, there will be a process. For every order, there will be a processing queue. First, it will go to the warehouse. From warehouse, it will be checked for the processing, whether at this delivery location it's been possible or not. Then it will go for next payment. Then once the payment is done, it will go for next hub, which is like packing, processing, packaging, and then at the time delivery. So this whole step-by-step process is handled with a queue that only this step should complete, then only the next step should get started. Otherwise, if you just schedule it with the help of APIs, you cannot manage the ordering. So that's why all the steps in terms of workflow, I would say, they put it into queue, and step by step, each and everything is happening. It's just a very hypothetical scenario that I'm giving. There are many more usages of queue in industry. And that's why when you go for interview, there will be some questions on queue as well. We'll see few either today or tomorrow, but today we'll start with the array questions, few questions. But there will be questions on queue as well, scheduling as well, just to know that how much you are familiar with the importance and the coding of queue. Okay, without wasting much time, let's see what kind of interview questions can be asked for array. A first simple question, very simple. There are two sorted arrays of m and n size, sorry, m plus n and n size, and you need to merge them. So you'll be given an empty spaces. So this is m plus n size, and this is n size, right? So output should look like this. It's a fairly simple, probably first round of data structure, and their first question can be like this. We'll quickly see how you can solve it. Now, rather than solving how or mugging up the interview questions from many sources available over the internet, we'll see how to think into the interview or how to think in data structure. The more we understand the thinking process with data structure, it will be easy for us to crack coding interview. We cannot mug up all the 10,000 questions, right? So we need to understand how to think. So we'll see how to think in this kind of interview question. Of a fairly simple, let's say I have an array like this, and I need to merge them. What can I do? First logic or first a basic thought that comes in our mind is that a simplest solution, that what we think, what should be the simplest solution? Just like merge sort, can I use that? Like I'll create a temporary array. I'll compare both 1 and 3, whichever is a smaller, I'll put it 1 over here. Then I'll move my pointer further. So let's say now my pointer is over here. Okay. And I'm then processing. Dash is larger or 9 or 3. So dash, I don't have to continue. So obviously 3, I'll put it over here. Now my cursor is furthermore. 5 or 9, which is larger? 5. I'll put it 5 over here and I'll move my cursor. Dash or 9, obviously 9. Then same way until 10, 12, and 14. A simplest solution would look like this. But if you see, to solve this question, you took an extra array or extra space, which is called order of n space complexity solution. So your solution is right, you are iterating over this in order of m plus n, plus you are iterating the same way on this in order of n. So together it's order of m plus n only asymptotically. Okay. So time complexity wise is the least one, but space complexity wise, you are using extra space, which space you already have in terms of dashes. Can we reuse that? So we need to think like that. Or in interview, when you give this solution, they will ask you, can you reuse this space, utilize this space which is empty or dash is given to you so that you don't have to use this? Can we do that? So we'll start thinking in that direction. Or whenever we are solving interview questions, we'll need to adapt this kind of thinking pattern. Can I do that? So we know, like, the dash or empty spaces are exactly is the size of n, right? So that it can be fitted, obviously. Then only then order of n plus n size array can be done. So if I put all of them blindly over here, 3, 9, 12, and 14, and my array will become something like this: 1, 3, 9, 5, 12, 14, and 10, whatever. Okay. And then if I sort it, let's say quick sort I use or merge sort, whatever I use, then it will be very, very, very simple: 5, 9, 10, 12, 14. I'm not using any extra space. This is also one of the solution, right? But think about it. What is the time complexity you used? Again, time complexity is order of m plus n to iterate over this, which is order of m plus 2n. 2 or numeric numbers are not taken into consideration in mathematical, in asymptotic way. So we'll consider order of m plus n. But once this is created, to sort it, what you will use? Order of m plus n log m plus. So it's a huge, right? Because previously you were solving in order of m plus n only. Now you are solving in order of m plus n plus sorting time of this. And quick sort or merge sort or whatever, it takes arbitrary space of same size, right? Order of m plus n log m plus n. So internally, you're using the space and time complexity more. So obviously, this is not the wisest solution. What should we do furthermore? So let's think what we can do with this array. In array, we can do reshuffling, or we can just migrate elements here and there. So what if I have an array like this, 1, 5, 10, or all the dashes, so all the empty spaces at the back side, or all the empty spaces towards the right side. If I have this, then the array 3, 9, 12, and 14, or 3, 9, 12, and 14. If I get such kind of solution, can I solve it in less time complexity? Now think, just like a merge sort I'm giving you. In merge sort also, we have two different arrays and we are comparing first element and we are storing it into a next array. The same thing can we do over here? I'll just see 1 is a smaller or 3 is a smaller. 1, so I'll copy 1 over here. Sorry, I'll copy 1 over here. And then I'll proceed. Can I do that? Yes. Second thing, as it's also sorted and from the smallest element, and this is also sorted from the smallest element, I can choose in a different way if I don't want to swap and do all the things in this direction. That, just a minute, I'll just erase. I'll just compare the last element of both, 10 and 14. Whichever is larger, I'll put it over here, 14. And now my pointer is pointing to 12. 12 and 10, whichever is larger, 12. I'll put it to the back, I'll move my pointer. 3, 9 and 10, whichever is larger, I'll keep my pointer furthermore. 5 and 9, whichever is larger, I keep it, move further. 5 and 3, whichever is smaller, I move it over here, sorry. 5. Point against small, this side. 1 and 3, whichever is smaller, I keep it over here. So I just replace it and then do it. Now in the same way, from the front also we can do, if all the empty spaces are at front, the same comparison, I need it or I'll do it from front. 1 and 3, whichever is smaller, I put it at front and move further. 3 and 5, whichever is smaller, I put it over here. Move further my pointer. 5 and 9, whichever is smaller, I put it over here. Move pointer. 10 and 9, whichever is smaller, I put it over here. And the rest of the elements will be copied. Like 10 and 12, whichever is smaller, I could put it over here. Then there is nothing. So rest of the elements 12 and 14 will be copied over here. Simple. Now, it seems that the question was fairly simple. But if you see, we had few edge cases over here, such like, what if this kind of scenario comes up? One array is exhausted, another array is left. Then will I just have to put all the elements in this side? The same kind of edge cases can come in this solution as well. So my point is, when we are working on creation of a solution, we should take 2 to 3 different cases and try to solve them so that we'll find it out all the edge cases. And note down some edge cases in your book when you're writing solution, or pen and paper, wherever you're writing a solution, so that when you gives this answer in interview, you know that, you know, these are the edge cases that I have thought through, and it will be a plus point for your interview, that they will think that, yeah, guy is taking a notes of all the edge cases, all the input types, all the assumptions that he has taken. Perfect. So let's start writing the algorithm on this, or pseudocode for this, and then we'll start writing the code for that as well quickly. Okay.
Can you repeat the test edge cases again?
I'm not writing all the edge cases. I have just written just one edge case, which for one example, we found it out. That was this example. So let's say 3, 9, 12, and 14 was the example. Okay. And I have kept like 1 over here, 3 over here, 5 over here, 9 over here, and 10 over here. Post that, because 10 was at the last and pointing over here, I found it out that there is now nothing left to compare, right? So nothing left to compare means either of the array is exhausted. Then what to do? Then rest of the elements, whatever are there, has to be copied as it is. Has to be copied as it is. So this is first edge case that we have encountered right now. If we take more such examples, more edge cases we will cover, right? So we'll see when we are writing the code, and then we'll try to understand that will it work for all types of input. Now, is there any assumptions we have taken in input, like there is no negative numbers or there is no positive numbers or something like that? No, nothing. So there is no assumptions we have taken. Just one assumption is that properly the array sizes of m plus n are there. That this is m plus n and the smaller size is n. That's it. Apart from that, and it's given in input. So nothing further assumptions are there as well. Okay. Now let's write it down, a pseudocode for that. In a simplistic way, it's that move elements to the right or left. As we have seen, it can be solved with both the ways. And empty spaces to the left or right, vice versa. If elements are at right side, empty spaces would be at left side. If elements are at left side, empty spaces would be at right side. So first, move that. First we have moved that, then what is the next step? The next step is to take pointers. Pointers means any variable which is pointing to the array. We know, like let's say a of I, if we want to say, then I is a pointer for me. So let's take pointers I and j towards the a and b's end, or I and j towards a and b's start. When to use end, when to use start, based upon the kind of logic that you're using. As I said, yep, over here, if 3, 9, 12, 14, right? If all the empty spaces are at towards the last side, I'll use pointer which is pointing to, let's say, I and j towards the end, at the end of both the array A plus A and B, and one extra pointer k towards the end of m plus n size array. If I'm using that all the empty spaces should be towards the front, then my I first pointer will be at over here, and 3, 9, 12, 14. Next pointer j will be over here for comparison, and k will be at the starting of beginning of the array. Simple. So this is well understood thing, right? So I'll move my pointers accordingly, according to the type of logic that I have used. And further, I'll put whichever is larger at the end or smaller at the first. As I said, if we are using this algorithm, then the smaller at first, or this algorithm, then the larger at last, right? This kind of placement I'll do. Correct? Now let's start writing about the code. That if I have to use this kind of algorithm quickly, what kind of code I'll write? So consider that empty spaces you are marking with, let's say, minus 99 in array, or minus integer, or integer min. Anything is fine with me. Okay, whatever kind of representation you want to use with in code, anything is fine. So what I'll do, move front, let's say I have written a code, move front of array I. Okay, what I'll do, if it's not minus 99, I'll move them to the front. Simple. And what I'm doing in the moving with the front, I'm just keeping two pointers, I and j. Okay, so I starting from, let's say 1, 2, dash 3, dash 9, something like that is there. Then what I'll do, I start from 1. If it is not minus 99, let's keep it. Not minus 99, let's keep it. If it's minus 99, then just swap it with next element. That's it. And I'll move it further. And I'll keep, let's say I swapped it at 3. My j, one pointer at the empty space will be kept it over here. So again, if I find empty space, move further with 9. Whenever I find a 9, move it with this. So a of I, j is equal to a of I. In that way, I'll move it. Simple. You don't write, please. So in a simplistic way, I move further all my pointers. So my array will now look like either this or this. Right? In a simplistic way, same way, you can write a code in which you are moving the empty spaces to the back. Now we'll see the merge array, which is similar to merge sort code. Not a divide part, but the conquer part. I equals to m minus 1, j equals to n minus 1 at the end, and k equals to m plus n minus 1. So what I'm doing is I'm considering, let's say my array is something like this: 1, 9, 5, empty, 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 3, 10, 12, and 14. So now my I is at m minus 1, j is at n minus 1, and k equals to m plus n minus 1 over here. All the elements are at back. Over here, I have written a code for front. So I'm merging all the solutions so that you can understand what if like this and what if like a different solution. So both the kind of logic we'll see, so that you can understand that it's easy even if you go for any of the solution. Now what I'll do, I'll simply process until any of the array existed. Until any of the array existed. That means there is no further elements to compare. Until that time, I'll move. What I have to do, Simple. I just have to compare both the elements of A of I and B of J. Whichever is a larger, I'll put it at K. So same logic. If A of I is a smaller and B of I is larger, the larger element I'm putting at the end. Larger element I'm putting at the end. So over here is a K, over here is a J, and over here is a I. Whichever is the larger of I and J, I'll putting it at the kth position. So A of K equals to B of J. J minus minus, whichever is written into that element, I'll reduce it. Else, so if A of I is larger, then I'll put A of I at the A of K's position in AI minus minus. And as I have kept an element at 14th position, kth position also will be reduced, so that in the next empty space, I'll put a lesser number than 14. Simple enough. Now, as we have seen an edge case, the same edge case we'll have to think over here as well. Right? That what if the while loop completes and the rest of elements are not copied? So can you guys think and write it down a logic after that, that if A of I is not exhausted or B of J is not exhausted, rest of the element I need to copy into rest empty spaces. Can you guys do that? It's kind of a homework. So fairly simple. Either you move front all the empty spaces or the back and you merge that. Simple enough. Simple initialization of a pointer. And if you are choosing to move it this way front, all the numbers to the front side, then your elements will be, or your pointers will be simple enough. Let me show you. Let's say you are choosing like this instead of this. Then let's say 3, 9, 12, and 14. Then your I will be at A of 0. J will be at B of 0. Correct? And K will be, so after sorting, let's say you ended over here, right? So this is n size array, and this is m plus n size array. So the index of this will be what? M plus 1. So K will be m plus 1. Simple. And just again, the same logic, you'll write it over here. So just first line will change, and the similar kind of logic you'll write it over here. Whichever is a smaller, that you'll put it into kth position and you'll increment it. Simple. So by changing just few points, you can differentiate both the algorithms. Okay. So this was the first simple, very simple algorithm. Now, for you guys to think, I'm giving one question as an, I would say, homework kind of a thing, okay? That if I have an array of numbers, something like this, let's say 3, 4, 9, 1, 56, 7, 12, and something like that. So this is the boxes of chocolates that I have. And I want to distribute it among number of children. So let's say number of children. So this is the array which I have. And the number of children are K. Let's say K is 5. Such that the children who gets the minimum chocolate and the children who gets the maximum chocolate, that's difference should be minimum, the least one. Then how can I distribute chocolate? You need to find it out. What is the least difference of your possible distribution? Think through it. Whatever we have discussed so far, from that, one of the logic will be applied over here. Sorting, the kind of merge sort, quick sort that we have used, or normal array operations. From that, you can solve this question.